Lesson 8, Multiplication and Division Word Problems. In this lesson, we'll hopefully use multiplication and division to solve problems about equal groups. We'll also learn how to write an equation to solve a word problem. In order to do this, we'll need to remember how to translate mathematical phrases into algebraic expressions, translate algebraic expressions into mathematical phrases, and translate mathematical sentences into algebraic equations. In the previous lesson, we considered word problems that involve addition and subtraction. In this lesson, we will look at problems that involve multiplication and division. Many word problems have an equal groups plot that can be expressed with this formula. Number of groups times the number in the group equals the total. See how the numbers in the following story fit the formula. In the auditorium, the chairs are arranged in rows with 15 chairs in each row. There are 360 chairs. How many rows of chairs were there? So in this particular case, we don't know the number of groups. The number of groups are the actual rows. So we can say it's something we don't know. We use the variable. We'll say it's x. And we're going to multiply that by the number in each group. The number in each group are the chairs, and there's 15 chairs per group. And we know that that's going to equal our total, and in this case our total is 360. Again, we've got to draw back on our understanding of fact families to know that something times 15 is 360, so 360 divided by 15 should equal the number that we don't know. And using our division algorithm, we find that the answer is 24 rows. Let's make sure that that would make sense. If I had 24 rows with 15 chairs in each row, would that come out to 360? I can quickly double check that using multiplication to say yes, that would come out to 360 chairs. Let's take a look at this next problem. The total cost for 5 student tickets to the county fair was $28.75. What is the cost of each ticket? Because each ticket is what we don't know, that's our variable. I'll use x to represent that. So we don't know the cost of one ticket, but we know that 5 times the cost of one ticket equals a total of $28.75. And here we've translated 5 student tickets. The tickets we don't know equals $28.75. To simplify 5 times x, we want to use the inverse operation, so it's divided by 5. Each side is divided by 5. Those cancel out. We're left with just the price of the ticket. And here we have x equals $28.75 divided by 5. And using our division algorithm, we find that $28.75 divided into 5 groups comes out to $5.75. That's our answer. Again, we want to go back and we want to take that all the way back to here. If I have tickets that are $5.75 and I have 5 of them, 5 times $5.75 should equal the product of $28.75. Let's take a look at one more problem. Cameron sorted 375 quarters into groups of 40 so that he could put them in rolls. How many rolls can Cameron fill with quarters? So we are given the total number of quarters, which is 375, and the number in each group, which is 40. We are asked to find the number of groups. So we don't know how many numbers are groups. I can use the variable n multiplied by the number in each group, which is 40. That equals our total of 375. So again, using our understanding of fact families, the expression 375 divided by 40 should equal our unknown number of groups n. So in this particular case, Cameron can actually only fill 9 rolls. He's going to have 15 quarters left over. So he can fill 9, so our answer would be 9 rolls he can fill, and he's going to have 15 quarters left that won't fill a complete roll. Go ahead and go on to your lesson practice. That's located on the blog, and then on to your written practice. Good luck.